Thank you, John. I have with me Tom Ward, who is part of the IBM team, and me and Tom has been working since last year on this new initiative. And since it's very difficult problems, I have been focusing on that work, and I make sure that Tom comes with me, and when we have certain engagement that academic are very tough, we went to MIT and to introduce that new problem. And I feel that it's an opportunity for Tom to describe what that new problem is in the concluding remarks, which will be a demo and so on. I would like to start this talk by actually referring to one of my favorite writers. As you see in my profile, I like Anglo-Saxon literature. Virginia Woolf was asked to give a talk in Cambridge to Newham College and Girton, a women's college, to women students. And she pondered, what is she going to really say that will really help future generations of writers, in particular women? And she said, oh my God, if you read in one of the books that culminated after she gave the lecture, it's actually called A Room of One's Own, that she just needed to give one message, which they could wrap it out of that lecture, carry it with them for life. And what is that message? That they need a room of their own. And many writers have been in critical area, have been looking into this for a long time. Even James Wood at Harvard English Department and many others have been studying what that room of one's own means. Does it mean that the woman has to have money in order to succeed as a writer? A space of her own, quiet, and so on, in order to concentrate and read and advance creativity? So, Tom and I are standing here today, giving this topic, AI, and how IBM leveraging AI. We've thought about it. I discussed this for hours with Professor Vinia Sanya in Essex University. I said, wow, what is the kind of message that this crowd would like to take from us? We come from a very big company that have been in existence for more than 100 years, and what could that message say? And as a reader of literature and history, I said, well, let's just look at throughout the history of IBM and see what has been very important that could bear on this AI today. And that's what we're going to do. We're going to try to show you how that industry have been disrupted over and over, a theme that have been echoed earlier by other speakers. And if that is true, and it has been disrupted over and over the course of 100 years, and most of the theory of disruption from Christensen at Harvard Business School is saying that big companies stand no chance, how come IBM still have a chance? So that is the start of what we'll try to show you in some few minutes. There's not enough time. I know that's such a big topic. As Virginia said at the beginning of that page 1 of that book, it's such a big topic to talk about women writing. So this one, too, is such a big topic to talk about competitive advantage in a phase of disruption. So what we will do is start and give you certain key model that will at least help you deduce that yourself. Look at this picture. It's been given as a Microsoft challenge for company to solve to see if you could, Tom, if you go next, if you could have a computer system that will recognize a woman sitting on a table with a giraffe and actually tell you that that's what is going on, discover it, without any training, and that a green bird is sitting on top of a bowl, or that a blue boat is sitting at the side of a building. A great success has been done in this area in actually capturing this, and the computer system, including Watson, as you see here, was able to do that with great accuracy. With great accuracy. But can we go beyond it? We have seen a lot of major advances in the last few years. In fact, since 2016, there have been a lot of things that have happened that have paved the way to people saying, wow, what we were actually saying at the beginning of the century or even in 1950 is beginning to happen. So, with that, AI is spreading everywhere. And in fact, we would even call it what, Tom?
Yes, so IBM refers to AI as augmented intelligence, not artificial intelligence, although that's commonly used, but augmented intelligence. How will it help us as humans to make better decisions, and how can all of the insights from computer systems better supplement what humans are doing and do very well? So our focus is really on augmented intelligence as opposed to artificial intelligence.
And this changes is appearing in all kinds of products, our products. It's appearing in software products. It's appearing in our cloud computing products. As you know, IBM been operating in 50 billion, 60 billion hardware company in the past. And cloud is taking a certain portion of that. And AI is playing in these products. And AI is playing in big data, as other writer and other speaker today have alluded to, and it comes in various forms: natural language understanding, vision system, and so on and so forth. But what is important to us, particularly as decision maker, is particularly those who are in big companies, CEO, CFO, and all those people that have decision making for spending the money, and what does it mean to them? In fact, in recent years, we actually have seen that it means a lot to them. It is part of their strategic agenda right now. In the last 18 months, in fact, Amazon have been aggressive in spending, in hiring and doing other things. IBM equally doing the same thing, and many companies, because they think that actually having these assets, the AI assets, gives you an advantage in the market. And it could make you survive that disruption that I alluded to earlier. And what about countries? What about country? In fact, it is becoming a security issue to make sure that your own nation should invest in AI. And China have dedicated so much money that it scared the hell out of us in IBM, looking at what China is doing, and the US government, and we hope that they should be reacting to what China is doing in terms of investment in AI. And Germany, France, in fact, just a few weeks, was it 1 week? When
there was a Viva France event, a lot of emerging technologists. We'll talk a little bit more about that, and a challenge for code where people can basically write code to try to help advance AI insights as well. And our CEO, Ginny Rometty, announced that at Viva France 2 weeks ago.
So in France, she went there with the French president, trying to invest a lot of money into this. In Germany, the same thing is doing. In fact, our center for IoT is in Germany, and a lot is going on in that country. And the German government equally is investing in this. Russia, talking about hacking election, okay? Hacking election. What next would they hack? What next would they hack? So it is a critical component, not just for firms and decision makers in firms, critical for nations. And it's a security issue. Security issue. So what does that mean to you? What does that mean to you? How I would try to help you is to show you what it means to IBM. And through that, perhaps, as a use case, you might step in our shoe to see the way we see it and how we make that decision to see that this is a priority for us. And it might help explain why a big company like us, which were regarded as an elephant can still walk, and perhaps an elephant will eventually disrupt. That is our goal. Tom. So, this thing called big data, it did not start today. It started in the beginning of the century, if even possibly just before the end. I've been trying to look at the archive, and I don't know if I will even have enough time. This week I was planning even to go to Oxford and look at PhD that were awarded beginning of the century in statistics in that college in Oxford, because one of the population model that we use, a Markov model, came because people were doing population model. And IBM came in there to count. IBM began to develop computers because they were called to count for the US government and other governments, the British government, to count the number of people that exist in a particular area and what the total population of the country is, was a tremendous importance for the country at the beginning of the last century. And that's how a tabulating machine came about, and that's how IBM was born. And after the war, and this even became more important for the US government. And IBM, we started developing programming model, COBOL, and so on, trying to get computer to actually understand, and that's how we came with System 360 that eventually, in the end of 1980, when Intel and Microsoft, this young guy dropped out from Harvard, showed up at our door and created Microsoft. So this story is not a new one, but we can see it with a new lens, because the history is there now for us to see what has been happening. And now we're calling it cognitive computing, and it's being resurfaced. And all problems resurface with a new look. And that's what we're going to see in the next chart. Yeah,
the only other thing I'd add here is the first two eras were very much about structured data, tabular, rows and columns. We're all very familiar with that, whereas the cognitive era is all about all the unstructured data, and more than 80 or 90% of the data is now unstructured, news feeds, images, and so forth. So unlocking insights from that unstructured data is all about the cognitive era.
Since this is a history discussion, let's look at what happened in 1960. After the dust settled, after the war, and after they had that big cognitive conference in psychology had at MIT, where Chomsky was in that building, okay, where they developed, the assignment Chomsky had was to create a translation from one language to another. In fact, I have a picture of Chomsky a few weeks ago, and we're having a chat. And I've not pushed him further about what was happening, but I will continue. I hope to have a conversation with him to really tell me what was happening before 1968. It was very important as a decade, 1960s. And the space program was created, Apollo space program. In fact, that's probably one of the excitement because it's the decade towards the end of my birth, and so on. And in 1997, I was, just before that, I was a student in South Kensington, and a major news, it's almost like today's CNN, a breaking news. A computer has beaten a Russian chess master. I remember that day well, and I also remember the conversation in the tea room on the 6th floor of electrical engineering building. Head of department, Ego Alexander, head of neural network in that senior tea room, and Ibman Dani. And the answer they were giving, whether this thing is cognition or not, whether machines are actually conscious to be able to beat a human being, The answer they were giving was that one big factor drives that machine to beat Kasparov, and that was speed of the supercomputer. That IBM have created this big supercomputer that are able to simulate future games, so they could walk and know the history of various paths, and therefore the mathematicians are so bright to implement it on that supercomputer so that they could know which path to take, and that's why they are able to outmaster the human brain. It was amazing if you're a PhD student. So, and I took interest in IBM at that time, and eventually joined IBM in 2000. And immediately we were set to work on this big ASCII supercomputer, huge. It had thousands of processors communicating with each other. And one processor would get a message and then computer and send to another processor, and they all coordinated in order to converge to a solution. And we developed that system. Eventually, it was packaged into the system that eventually defeated Jupiter. Don't why not tell them?
So just the reference to Jeopardy 2011, very much towards teaching Watson and applying Watson technologies for question and answer. Now, at that time, the only problem it could solve was Wikipedia trivia-related questions, and it's advanced substantially since then. But 2011 Jeopardy champion beat the greatest champions of all time in the history of that game show, which was all about identifying questions and answers around trivia. So since that launch in 2011 for unstructured data insights, we've basically been applying it for other areas where we can solve similar unstructured data problems. We'll show you an example later.
Okay. So this is me in this ASCII purple supercomputer. Very expensive. Why? They have flew in. They went around the world. I just sat at Imperial. I received a call from IBM that there was a model we were developing, a Markov model, that was going to be applicable to this supercomputer. And the other thing was that the neural networks that we were trickling with, they were interested in this kind of thing. We don't have time to go into the depth of some of the scientists that were involved in the money that IBM spent on this. It became a topic for me. It became one topic is that the technology itself, the patterns that come out of Mark Davis' model, Markov model, connected with Ego and Mamdani work, was just big topic and with pattern in it. But another one was the business model itself. So I became puzzled. How come that one could get a company and create a model that actually show you that you can do better? Because in the course of doing all those things, Sun was our primary target because we wanted to win market share from Sun. So we created a model. We have a model of the supercomputer and all that. We also have a model for Sun Microsystem. And we're comparing them. And we're providing recommendations, both technical and business, to our senior executive. And we predicted. You are not seeing that part of the chart here, that if things remain the way it is, if you're looking at the market share at that time, at 2003 going upwards, there are certain parts you don't see. But what you're seeing here in the red chart is Unix, which is Sun Microsystem combined with IBM AIX. And you're seeing the open standard Linux combined with Microsoft. And you see that the open standard and Microsoft is going to disrupt and just get IBM and Sun Microsystem out of that space entirely. It's not an easy experience. And not even that coming from modeler, people who can actually get data to explain a phenomenon of business. And what happened? We predict Sun Microsystem will have problem. We took company, look at their balance sheet, run this model, and we predict Sun will have difficulty. There are 35 companies in the tech sector. We saw that out of those 35 companies, those in terms of free cash flow, if you ran them, and you run all those kind of models, you see that software companies were doing much better as time will be going on. Hardware companies struggling. And those that are mixed, such as IBM, mix of software and hardware would be somewhere in the middle. In the nutshell, one message from this, and I would like to go to the next slide before I summarize that message. Done. Next slide. Sun Microsystem, as an example, okay? They are disruptive. They came there in the window, in the workstation, what used to be called workstation in 1986 or something, if you look at the history of computer system. And they were great. There's something unique about this disruptor. So Sun Microsystem was disruptive. See how the stock was going out in those days? These guys are similar. Facebook. This guy, young, dropped out of college, okay? And they come in there, and people like IBM incumbent cannot survive. They really cannot survive. They cannot survive. So that is the message. The message is that you need money. You need a room of your own. And to get that room and protect it and still having a competitive advantage there, you need to spend it wisely. You need to choose the right disruptive technology. And that's why we're moving into cloud. We're moving into cloud, as you see in the next chart. And we'll rush through this chart. The world population, in terms of 7 trillion, and GDP is 75 trillion, okay? And only 2 trillion is in AI, okay? And even when you're shifting a little bit in IT, it's actually 1 trillion. That's the gray area of AI, and so on and so forth. China is growing much better in that area. And in the United States, growth in terms of spend is much harder. So how can you compete? You can only compete by taking market share. And that can help explain some of the shift that is occurring there and why IBM is shifting more towards AI and this technology. Last chart in this sector. So now, that 50 trillion, that 50 and 60 hardware market and IBM and Sun were in there now, it's being replaced by this almost 58 billion market of AI that we're currently chasing. And this is just for AI. This is quite huge. If you combine with cloud and software as a service and so on, this is the kind of area in which we are moving it. And with that, I will hand you over to Tom, who will take you through our risk insight, this new thing that me and Tom have been playing with in the last 1 year.
Great. Thank you very much, Appolo. So rather than just tell you the academics of it, we'll give you a live demonstration to give you a sense for it. But basically, this is how do we apply artificial intelligence to improve insights for our supply chain operations. This is one of about a dozen different applications that we've developed within IBM to help improve our overall operations. We've been doing monitoring supply chain risk for probably 10 or 15 years. There was a guy in the middle of Germany called Hans, and we basically used Hans to teach Watson what Hans learned over 15 years on how to mitigate and identify supply chain risks. So took a whole bunch of different information, different sources, and basically took social media feeds, took information from what's coming out from Twitter. IBM owns the weather company, so we have the latest weather forecast and all of that information. All of that information is integrated together, visualized. We overlay what's being said in social media reports, Twitter feeds with what's occurring on the ground for a live risk event. And with that geospatial intersection, we are able to identify what suppliers are in harm's way, what IBM locations may be at risk, what IBM clients' data centers may be at risk at any given time. And we pass all that information so that we can identify and mitigate those risks. So just a quick demonstration of what that looks like. Bear with me for a moment. Rather than trying to tell you about it, I figured we would just show you what it looks like. So this is what the Risk Insights application looks like, the home screen from it. And here's an example of a typhoon. Last year, there were over $300 billion of losses from major hurricanes, Irma and Harvey and Jose and Maria all had huge impacts across the US and also other parts of the world. So what we knew days in advance were, here were all the locations where we had IBM sites or supplier locations that were in harm's way, and we knew to be able to precisely say who's in harm's way, what do they produce, what do we need to do to mitigate that risk so it doesn't impact our business. And so there's just the geospatial engine. What you see lit up in yellow are all the locations that are in harm's way. So the geospatial reference is interesting, but what accompanies that further is the social media analysis. So we're ingesting literally thousands of articles on every single day, not just about these risk events, but also what's being spoken about these risk events. So what are the wind speeds that are being reported? What are the locations that are referenced in the news articles? What is the impact that's being said about airports, infrastructure, ability to get people, goods, or services out of that region? So all that information is provided directly to a risk analyst, and the weather effects are also occur on a live basis. So you see from that information, we're able to identify those different opportunities that are out there. Now, just in the last 12 hours, I looked at our Risk Insights application. There's been a 5.4 earthquake in Japan. There have been flooding risks that have occurred through Indiana. There have been there's a labor strike that's going on in China right now. So all of these different events may be impacting us at any given time. So knowing about an event is interesting. What we do is we pull across many, many different services. So what I'm showing you now is a live feed for, in the last 24 hours, how many different potential risk events are out there that may impact our points of interest. And you see at a glance, there's probably 200 things. So as a risk analyst, I'm like, you could be very nervous and Chicken Little, the sky is falling somewhere in the world, does it hit me or not? And what we've established is the ability to take and ingest all of those events, set a profile that says, all I care about is data centers that occur in one portion of the world, or I only care about supplier locations that occur in a different portion of the world. So we set parameters that customize a user's experience for that, and out of those potential 200 events, basically it boils down to, let me just, there's a view of, there's one impact that may occur to IBM's locations. So what you see is blue dots are our supplier locations, red dots are our IBM locations, and it boils down to, out of those 200 events, at any given time, we only care about this one particular thunderstorm in the last week that was going to hit in that geospatial area. So rather than being a Chicken Little worrying about 200 potential events that are out there, we can very precisely teach Watson how to identify the events, identify historically how they compare with previous events that have caused disruption to our operations, and in effect, identify in advance or at the time of the event whether or not we need to mitigate that and take an action relative to it. So it's just a small example to give you a sense for how artificial intelligence can be applied to a business problems, taking massive amounts of data and getting that insight on a real-time basis. So with that, I'll turn it back over to Appolo, and if you have any questions or comments, we're happy to take them and address them as they may come up.
Thank you, Tom. So, go back to this Virginia Woolf question. Virginia Woolf question. She was saying that in order to be successful, you need a rooms of one's own. You need a space. A woman, you want to succeed, she look at throughout the history of successful writer, look through Shakespeare, and even ask if Shakespeare could have been a woman. And the conclusion was that the only way to succeed if you are a woman at its time in 1920 is that you need your own space, and that you are on quiet space to be able to study, write, without the other obstacle in life. If you are at IBM, like we are, an incumbent, if you are IBM like we are as incumbent, you're faced with a lot of disruption. You look at through all that history of IBM competitors. You see that these young drop out from college will continue to disrupt you. And the message we have, you can read it for your own self. We embrace that open source. We continue to invest in those, work with those technology companies. We continue to invest a lot in R&D. If you look at R&D on top companies in tech sector, IBM have always had a ratio of R&D versus revenue much higher. So it's not an easy one. And with Today AI, we are doing the same. We have here Mike Hegel here in London, and he's one of our sales lead in analytics for London. And you know, we're glad that you're here with us today, and Tom working on the Watson team, trying to leverage it to weather. And there are other IBM teams around in the UK and the US, leveraging to other things, healthcare and so on. So with that, we conclude this talk.
And we're more than happy for any questions or comments. Yep. Thank you.